Chapter 5 is all about measurement. We first talk about US standard measurements and the great mathematical way to convert between different measurements. This technique that we use is called unity fractions. Let's look at this table here. I've created this as just a list of a bunch of common conversions that's available to you. And let's look at the first one here on, if I can highlight it here. Yep. This one here for 1 foot equals 12 inches. So the unity conversion that we can do with this, if 1 foot equals 12 inches, then I can write this as a unity conversion by doing this. We can write it as 1 foot over 12 inches or 12 inches over 1 foot. And this is a fraction that we multiply some quantity by to change the units. The important thing to note is which one do you do? Well, you always do it so that the bottom will end up canceling or the top ends up canceling, whatever your situation is. I'll show you that here. If you wanted to change 4.5 feet into some number of inches, what would we do? Well, we take 4.5 feet, we put it over 1 since there's no fraction there, and we multiply it by one of these unity fractions, either this one or this one. We don't want feet, what we want is inches, so inches are going to go on top and feet are going to go on bottom. The reason why is because if feet are on bottom and feet are on top, they end up canceling. And that's what we want. We want to cancel the unit. Now we just need to fill in the numbers. Well, 1 foot equals 12 inches. And you see that we get 4.5 times 12 over 1 times 1. 4.5 times 12, 4 times 12 is 48, but 0.5 times 12 is 6, so we get 54. Just use a calculator for that, obviously. I should write inches here. Inches, and that of course just gives you 54 inches. And so as long as the units end up canceling the way you want them to, if the units look good in the end, that means you've typically done the problem correctly. This is a fantastic way of checking your answers and your work, is to make sure the units end up correctly, and then you've probably done the multiplication right. Now, of course, you can string these things together. We can keep multiplying by different unity fractions to keep changing the problem, right? If I said like, let me highlight it here. If I use this one instead, like, let's say I had like 4 yards, and then I can multiply this by, what's the unity fraction here? It says 1 yard equals 3 feet. So I could say 1 yard equals 3 feet. I can multiply it again by 1 foot equals 12 inches. And what you see here is that the yards and the yard cancel, the feet and the feet cancel. Now we're left with inches. So now all we have to do is go 4 times 3 times 12 over 1 times 1 times 1. 4 times 3 is 12. 12 times 12 is 144 over 1. These are, of course, in inches. That's the only unit that's left. And this gives us 144 inches. So we've converted 4 yards into inches by doing 2 unity conversions. The first between yards and feet, and the second between feet and inches. Okay, let's just try this out with some problems here and see how it goes. 26 feet equals how many inches? Well, we already know how to do this. We do 26 feet over 1 times 12 inches over 1 foot. And you see 1 on top, 1 on bottom, they cancel. So we really just get 26 times 12 inches. Let me grab my calculator, make sure I don't mess up. Yep, 312. 26 feet is 312 inches. All right, 14 pints to how many quarts? Well, we know we have to do 14 pints over 1 times by what unity fraction? Let's go back to the table here. We're looking for pints and quarts. Okay, so I can remove these. These are no longer relevant. Pints and quarts, and pints and quarts are both volume measurements. So I can look underneath volume here, and I'm looking for pints and quarts under volume, or sorry, liquid capacity. It's a volume, but it's a liquid capacity that they use there. 1 pint, 1 quart equals 2 pints. That's what I have. The rest of this here we don't have to worry about. The 32 fluid ounces, that's not part of a problem. We do have 1 quart equals 2 pints. 1 quart equals 2 pints. We have 1 quart equals 2 pints. Make this a little smaller here. Okay, so how do we do this? We can either do 1 quart equals 2 pints, or we can do 2 pints equals 1 quart. Either way, like it's the same. It's the same unity fraction, but what does our problem require? Our problem requires pints to get removed, so we need to have pints on bottom, which means quarts have to be on top, and we have 1 quart equals 2 pints. That's how you set up and choose your unity fractions. Okay, cancel the pints. We're left with quarts, which is good. 14 times 1, 1 times 2, gives us 14 over 2, which both can be reduced by 2. Or, well, you can also divide 2 into 14. It gives you 7. And I can just keep the units in. We get 7 quarts. 14 pints is the same as 7 quarts. 9 yards equals how many feet? Right here, we have 1 yard equals 3 feet. We have 9 yards over 1 times, we want yards on the bottom, feet on the top. That way the yards end up canceling. And 3 feet is 1 yard. So 3 feet is 1 yard. 9 times 3 on top, 1 times 1 on bottom. That gives us 27. And of course the unit is in feet. Okay, 12 ounces equals how many pounds? 12 ounces equals how many pounds? This right here is pounds and ounces. Maybe a different color here. Make it stand out more. 1 pound equals 16 ounces. So if we have 12 ounces over 1 pound equals 16 ounces. So we want to get rid of ounces and have pounds. So ounces go on bottom. That way they cancel. Pound goes on top. 1 pound equals 16 ounces. 12 times 1, 1 times 16. These are pounds. 12 over 16 pounds. We can reduce top and bottom by 4. Divided by 4 gives us 3 over 4 pounds. 3/4 of a pound, 12 ounces. All right, 3.5 gallons equals how many quarts? For that one. Gallon to quarts. Right here. 1 gallon equals 4 quarts. So 3.5 gallons. Gallon, we want quarts. That way the gallons cancel, top and bottom. 1 gallon equals 4 quarts. 3.5 times 4 over 1 times 1. It gives us 14. 14 over 1, and these are quarts. 14 over 1 is just 14. 14 quarts. All right, 2.43 tons equals how many pounds? 1 ton equals 2,000 pounds. So we have 2.43 tons. 1 ton, that goes on the bottom, so we cancel the units here, equals 2,000 pounds. Over 1 times 1 gives us to be 4.86. 4,860 pounds. There's 60 minutes an hour. I don't have to look that one up. It is on the table, but that one I know off the top of my head. So we want to get rid of minutes, so minutes go on bottom, hour goes on top. There's 60 minutes in 1 hour. We get just multiplying straight across. 250 times 1 is 250. 1 times 60 is 60. Of course, the minutes cancel, and we have only hours on top. Cancel out to 0, and they cannot reduce. This probably would look better as a decimal number. I mean, it's a repeating decimal, but I'm just going to round to 2 places. 4.17 hours. 25 over 6 is an exact number, so whatever the problems ask you to do, that's what you should write it as. Okay, 5.5 miles equals how many yards? That I do not know off the top of my head. So let's go back up here, get rid of some of these orange lines here, and we're looking for yards to miles. This one right here. It says 1 mile equals 5,280 feet and also equals 1,760 yards. So 1 mile equals 1,760 yards. .5 miles then. Miles on bottom, yards on top. 1 mile equals 1,760 yards. Now you can see the miles cancel. 1 times 1 on bottom doesn't mean much, so we're going to just do 5.5 times 760 yards. And that gives us 9,680 yards. Okay, there's 24 hours in a day. So 1 day equals 24 hours. I hope you're seeing how I'm setting this up. I always have the unit that I want to get rid of on opposite sides of the fraction, and the unit I want I leave on top or on bottom depending on what you're doing. Okay, 4 times 24, that's 96 over 1, which is just 96. Okay, 6,600 feet. That should be a lowercase m. It should just be miles. Over 1 equals, this one I do know on top of my head, there's 5,280 feet in 1 mile. And of course, the feet cancel. Now we get 6,600 times 1 is 6,600. 1 times 5,280 is 5,280. These are miles. Cancel that. We can divide by 2. I'm just going to actually find the decimal number by doing the division. And I get 1.25 miles. All right, let's look at some application problems. All right, instead of going back and forth between the unit conversion table, I have one printed off for the problems I'm going to do. I'm just going to look at that That's how I recommend you doing these types of problems, is having a print off or another computer screen or on your phone or something like that, to where you can look at it and not have to switch back and forth between the problem. So that's how I'm going to do it. Okay, for this one we have a contractor is excavating a basement. The finished floor is at an elevation of 148.25 feet. The basement floor is 8 feet below this, and then an additional 9 inches must be dug out for the floor and the cinder fill. What is the final elevation of excavation? In other words, how much must be dug out of the elevation of the 148.25 feet? So what we're going to do here is just take the location of the finished first floor line and then subtract off the 8 feet below the finished floor line. Okay. And then it says, and an additional 9 inches must be dug for the floor and cinder fill. That means we have to subtract off another 9 inches. Now, we can't just subtract everything like this. The reason why is because we have different units. If you just subtract this like there, I mean, you could do that, but your number is going to end up being meaningless. You have to have all of the same units to do addition and subtraction. So we need to change, since this one, this is in feet, this is in feet, this is in inches. I'm going to change inches to feet first and then do the subtraction. So 9 inches, we have 12 inches equals 1 foot. And you see the inches cancel. Now we have 9 over 12, which is, we want decimal numbers here, right? We have a 0.25, 0.00. 9 over 12 is going to be 0.75. And that's going to be in feet. What we're really saying here is that we're subtracting 9, not 9 inches, but 0.75 feet. And now all the units line up nicely for us here. So doing the subtraction gives us 148.25 minus 8 minus 0.75, 139.5. And I'm going to add an extra 0 on the end there because all of these things have 2 decimal places after the 0. So I'm just going to keep it to be the same kind of number. 2 decimal places. That gives us 139.50 feet. That's how much the final elevation of the excavation is going to end up being. Okay, here we're cutting off 8 3/8 inch pieces from a 20-foot stock. We need to allow for a 3/16 inch kerf. All you have to do that is just add 3/16 onto 8 3/8, and then you can just divide that out. Now, of course, the problem here is that we have inches and we have feet. So let's take the foot and change it to inches. The inches are a little bit weirder numbers. So let's change the feet to inches to make it, not have to convert these weird numbers, the 8 3/8 to feet, and that would take more work probably. So let's go 20 feet over 1 times, there is 12 inches in 1 foot. That way they cancel there. And really we have 20 times 12 over 1 times 1, which is 1. 20 times 12 is 120, 240 inches. So we're saying, how many times does 8 3/8 plus 3/16? Let's actually convert these to decimal numbers and see what kind of a number we get. Okay, I got 8.5625, and that's a terminating decimal, so I'm just going to use that. we're asking the question, how many times does 8.52625 go into 240? In other words, how many 8.5625 piece cuts can we get off of 240-inch stock? Okay, 240 divided by 8.5625. I have 28.029, and then it continues on. What this means, though, is that we wouldn't want 0.029 of a piece. We only get 28 pieces that can be cut off to their full amount. All right, this one will be a little bit different. We're still using the same idea, the unity fractions, but what we're trying to get in the end is going to be a little different from what we've done before. We've taken a unit and converted to a different unit. Here, we're taking the reservoir has a capacity of 9,000 cubic feet. We want to change cubic feet into a time because it says, how long will it take? That's a time measurement. So we're converting between a volume, a capacity, into a time. And we're going to use the given conversion between gallons and minute. That's a ratio between capacity and time. Now, the problem, of course, is that we have 9,000 cubic feet and we have 250 gallons. So our first goal is to take 9,000 cubic feet. I'm going to write like this. Cubic feet is the same thing as feet cubed. The feet cubed is more natural when you're doing the mathematics because you can actually use that idea in the conversion. We're not going to use it here, but it's just good to get that kind of established in your head. We need to first change cubic feet into gallons. Looking at my sheet, I see we have 1 cubic, or like this, cubic foot equals 7.48 gallons. That's what I see on my sheet. So I'm going to multiply it by 1 foot cubed over 7.48 gallons. Now I can use this ratio here, which says 250 gallons per minute, or per 1 minute. And I can put it in here like this. I can say 250 gallons per 1 minute. All I've done here is just flipped it. And the reason why is because now gallons cancel and feet cubed cancel, and the only unit we have left is minutes. And so we've converted between a capacity, and the final unit we have is a time unit. That's how we can do it. We use some kind of given ratio like this that converts between them. Okay, now all I have to do is the mathematics. On top, we get 9,000 times 7.48 times 1. The times 1 doesn't matter. 1 times 1 times 250 is 250. And this is going to be in minutes. I'm going to do this on a calculator. 7.48 over 250. And I get 269.28 minutes. You can, of course, convert this to hours if you want. It didn't ask for that, so we'll leave it right there. It's 269.28 minutes to fill a 9,000 cubic foot reservoir at 250 gallons per minute. Okay, here we have a designer that's pricing wool carpet. She finds a $139.50 per square yard. I'm going to write that as yard squared at one store, and $16.65 per square foot or foot squared. Which is the better by? That's the first question. So you can see that we can't directly compare these two because they're not in the same units. We can either convert yard squared to feet squared or feet squared to yard squared, whichever you want. Looking ahead, it says here that we're looking for square yards. So I'm going to convert this one here into dollars per yard squared. To do that, I'm going to look at my sheet that says 1 square yard equals 9 square feet. 1 square yard equals 9 square feet. Okay, so now let's multiply this thing by, we want to get rid of the feet squared, so that's going to go on top because it was originally on bottom, and that way they cancel. And we want yard squared. 1 yard squared equals 9 square feet. Doing the multiplication gives us 16.65 times 9, 149.85. This is going to be dollars per yard squared. So which one's the better buy? Well, not this one, right? This one is lower costing. This one's the better buy. And then how much will she save on 166 square yards? We need to find the price for both and then figure out the difference. And that's how much she would save buying the cheaper one. So here we're taking 166 square yards and converting it to a dollar amount. Well, we have our conversions right here. This is the one that we want to use because it's cheaper. This is the other one. That's how we convert between yards and dollars. So for the green, we're going to do yards are going to be on bottom, 1 yard squared, and dollars are going to be on top, 139.50. You see that the yard squareds cancel. And doing multiplication, we get 166 times 139.5. It gives us $23,157. All right, for the next one, same space. Now we're doing the blue. 149.85 over 1 yard squared. Of course, again, the yard squared cancel. That's what we need. Do the multiplication. I get 24875.10. All right, now I'm just going to subtract. I'm going to subtract the bigger minus the smaller. Finding the difference and how much she saves. All I'm doing is this. And that tells me how much she saves going with the cheaper carpet. And she will save $1,718.10. That's both of the parts of that question. Okay, so we have a sewer line that has a flow rate of 1.25 million gallon MGD, which is million gallons per day. We need to convert this to cubic feet per second. So we have to do two kind of conversions. Go from million gallons to cubic feet and day to seconds. We can do this all in one long line of the unity fractions. Now, the first thing that we have to do is change million gallons to gallons because there is no direct conversion between million gallons and cubic feet. You can probably find one if you look hard enough, but I don't have one on my sheet. So I'm going to change million gallons per day to gallons per day. And really all you have to do that, if 1.25 million gallons per day, and this equals 250 gallons per day. You see, all I did was I multiplied this by 1 million. That gave us regular gallons per day. Hopefully that makes sense. You can of course just go like 1.25 mgd over 1 times, so 1 million, like 1 million gallon equals 1 million gallons. That's why I didn't really write it out like this. It's quite a simple conversion. It's just a way of using smaller numbers. They typically do that by just like moving the decimal point in to make it 1.25 rather than 1,250,000. 1.25 is much easier to work with. Okay, now that we have 1,250,000 gallons per day, 1,250,000, this is going to be gallons per 1 day. Now we need to multiply it by a string of unity fractions to convert gallons to cubic feet per second and days to seconds. Okay, let's first convert gallons to cubic feet per second, or to just cubic feet. Looking at my sheet, I see 1 cubic foot is 7.48 gallons. Gallons are going to go on bottom. Whoops, it's 7.48 gallons equals 1 cubic foot. Okay, so this will actually give us the cubic feet. Oops, I forgot to write the cubic feet there. So that's good. We now have the cubic feet. Now we need to change day to seconds. You can just directly, if you know the conversion straight from day to seconds. I do not, so I'm going to convert from day to hours. So in 1 day, there's 24 hours. And now you can see the days cancel. Now we have hours on the bottom. 1 hour is 60 minutes. Now the hours cancel. And finally, 1 minute is 60 seconds. Actually, it's just S. And the minutes cancel. And what do we have on top? We have feet cubed, nothing, nothing, nothing. We have feet cubed on top. And on bottom we have nothing, 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 nothing seconds. Feet cubed per second, that is cubic feet per second. So we have the correct units. Now all we have to do is multiply everything out. On top we just have 1,250,000 over 7.48 times 24 times 60 times 60. Doing that multiplication and the division gives us 1.93. I'll stop 2 decimal places because this number has 2 decimal places in it. That's going to be cubic feet per second. They have it written as CFS. And there we go. Oh, it actually says around to 2 decimal places here. So that's what we did there. All right, next one. With cast aluminum, we're changing the density from 160.0 pounds per cubic foot, converting this into ounces per cubic inch, and then we're going to round to 2 decimal places. So first off, let's convert between pounds and ounces. 1 pound is 16 ounces. And the pounds cancel. Now we have ounces. That's what we want on top. On bottom, we want cubic inches. So we need to convert from feet cubed to inch cubed. Looking at my sheet, I see 1 cubic foot equals 1,728 cubic inches. So 1 cubic foot is 1,728 cubic inches. And you see the feet cancel. Do a double mark there. On top we have ounces. On bottom we have only inches. Ounces per cubic inch. That's what we want. So doing the multiplication, per 728 is going to be ounces per cubic inch. 160 times 16 over 1728. Round to 2 decimal places, that gives us 1.4814814881. This is second decimal place. Look at the next one. That's not 5 or greater, so we just drop it. 1.48 ounce per inch cubed. All right, this one's a little bit different. We're still going to use the unity fractions and everything, but here we're trying to figure out what is the maximum time allowed per container. So we're actually trying to find a rate here. And so we're not converting from one unit to another unit. We're just actually doing a division to find a rate. We're trying to figure out time per one container. Time per container. So in other words, we need to have a time measurement on top. We have 7 minutes and 40 seconds. We could say, it says round in the nearest second, so we're going to say seconds per container. Seconds per container is what we're going to have in the end. Now the problem is that we have 7 minutes and 40 seconds. That's the time given as the maximum time allowed. We cannot do 7 minutes and 40 seconds inside of a division. We need to have only one single unit. So we're going to convert 7 minutes into seconds and add that on to 40 seconds. So 7 minutes over 1. 1 minute has 60 seconds. Just S. So 7 times 60 is 420 seconds. And then 7 minutes and 40 seconds is going to be 420 seconds, which is 7 minutes, plus 40 seconds gives us 460 seconds. 460 seconds is the maximum amount of time allowed for 24 containers. So how much is the time per one container? Well, if there's 460 containers, or 460 seconds per 24 containers, we'll just do C, I guess. Then we can just divide them out to figure out per one single container. That gives us 19. Make sure I'm writing this correctly. 19.16 repeating. This is going to be seconds per one container. When you do the division, what you're doing is you're actually changing this to 1 and then dividing this into this number there. So now we have 19.16666 repeating seconds per one container. It says round to the nearest second. That's just going to be this place here. We look at the next one. It is not 5 or greater, so we drop it. That's going to be 19 seconds per container. That's the maximum time allowed. Okay, we have a flat and bare half-acre parcel of land. A 2,800 square foot house is built on this, and 600 square feet are needed for a driveway. So how much of the land is left for landscaping, having a lawn, having a garden, all those kind of things? Well, we have two things of square feet. You have 28,000 square feet and 600 square feet, and this one is in acres, half acre parcel of land. So let's first change acre to square feet, and then we can see how many square feet remain. So 1/2 acre, that's the same thing as 0.5. All right, this 0.5 acres over 1. Looking at my sheet, let's see, 1 acre equals 43,560 square feet. So 1 acre equals 43,560 square feet. Or you can write it as SQFT, but you should probably get more in the habit of writing like this. Okay, now you see that the acres cancel. And now all we have to do is multiply 0.5 times that, let's see, 0.5 times 43,560 gives us 21,780 square feet. Okay, how many square feet remain for landscaping? So we're taking off of this square footage the house and the driveway. So all we really need to do is subtract from this 2,800 for the house and subtract off of that 600 square feet for the driveway. Doing that gives us 21780 minus 2,800 minus 600 gives us 18,380 square feet, and that's what remains for landscaping. Okay, for this problem we have a lady's trying to figure out if it's better to live in the suburbs or further out, or sorry, rent an apartment in the city or one in the suburbs. So if she lives in the city, she can walk or bike to work, and then if she lives in the suburbs, she has to drive. However, the apartment in the city is $1,400 per month, and the one in the suburbs is $1,200 per month. But of course, if she has to drive, then the cost of gas mileage is going to be in there as well per month. So which would be which saves her money? We're not concerned about anything else besides if she lives in the city, she doesn't have to drive a car. If she lives in the suburbs, she does have to drive a car. So in the city, her monthly cost is $1,400 for just the apartment. So that one's actually already done. In the suburbs, her monthly cost is $1,200 plus, let me write this a little bit more spaced out, plus the monthly cost of gas. So I'll say monthly cost of gas. How do we find this monthly cost? That's what the rest of this is kind of saying here. It says she's going to drive 60 miles per day for 22 days in a month. And her car gets an average of that, and this is the average price of gasoline. So all this information we can use to find the monthly cost of gas. First off, how many days is she going to drive in? She's going to drive 22 days per month. So what we're going to do is we're going to take 22 days. Really what we're doing here is we're saying 1 month of driving over 1, multiplying by, in 1 month, we have 22 days of driving. Now 1 month it was like 30 days, 31 days, but what we're doing here is 1 month of driving. 1 month of driving. This is 22 days of driving. We're not converting between days and month like in general. We're converting days and month in our problem. Well, this still creates a unity fraction because she does do on average 22 days per month. That was given to us here. 22 days per month. Okay, now we can keep going though. So she drives 60 miles per day. So in 1 day of driving, she drives 60 miles. And we know her car gets a gas mileage of 24 miles per 1 gallon. Okay, now we can multiply by the $250 per 1 gallon. And what you'll see here is that we have month of driving, days of driving, miles, gallons, and the only unit we're left with is dollars on the top. That means that all of this multiplication, if we do it where is going to give us the monthly cost of gas. Okay, multiplying this out, I get 1 times 22 times 60 times 250. And then on bottom we have just 24. That gives me $137.50. That's the cost of driving for 1 month on average, which is a total of 15750. I meant 12. No, 1357.50. So it's actually cheaper for her to live in the suburbs than to live in the city.